All right, geometry, you have made it through chapter 6. We've got one last section to go. And just in case you were wondering, section 6.6, trapezoids and kites, is kind of the weirdo of the whole thing. You know how every family has like a strange one? Might not be you, might be you, I don't know. Section 6.6 is the strange one of the family, the chapter family, because it's trapezoids and kites, but they are not parallelograms. Everything else that we've talked about, 6.2 to 6.5, has been parallelograms. Trapezoids and kites fall into this because they are four-sided figures, and that's the only reason. So I know that you know what trapezoids are. We're going to start with those. We're going to go through a table just like we do before, and we'll kind of talk from there. So first of all, a trapezoid is a quadrilateral, so it's a four-sided figure, and it has one pair of parallel sides. We call that one pair of parallel sides. Hi, Mr. Front. We call the one pair of parallel sides the bases. So the bases, we typically think of them as the bottom and the top, but I could rotate it and put it sideways. That'd be fine. The other thing about about trapezoids, is if the legs are congruent, it's an isosceles trapezoid, just like an isosceles triangle has at least two, I know being technical, congruent sides. Well, legs have isosceles trapezoids have two congruent sides. It happens to be the two legs. So isosceles is a term you've seen before, and you know that. So here are some properties or some rules about trapezoids. The first property, I've tried to put an appropriate picture in with it. The first property is, if we're talking about an isosceles trapezoid, not triangle, not sure what I was thinking when I typed that out. In an isosceles trapezoid, each pair of base angles is congruent. In an isosceles trapezoid, each pair of base angles is congruent. So notice, the important part you have to notice is that GF and HJ are congruent, so that makes it isosceles. So that means that angle G and angle H are congruent because that's one pair of base angles. And then it also means that angle F and angle J are congruent because that's the other pair of base angles. Now, G and F are definitely not congruent, right? Because G is acute and F is obtuse. So you can only do the pairs together, the two from each base. Next rule, next property of a trapezoid is, if it has one pair of congruent base angles, then it's isosceles. This is backwards. This is the same thing, but backwards. So if angle L and M are congruent, angle L is congruent to angle M, then we know KL has to be congruent. The legs have to be congruent to each other. But that also tells us the other part of it, which is that other pair of base angles also have to be congruent. So angle K and angle P, angle K also has to be congruent to angle P, because that's the rule in an isosceles trapezoid. So if you've got one pair of base angles congruent, it tells you a bunch of other stuff. So just be aware of it. It's one tricky way to give you information without giving you information. Last but not least, in an isosceles trapezoid, the diagonals are congruent. So if I've got those two legs, in this case it's QT and RS, are congruent, that means my diagonals, QS and RT, have to be congruent to each other. I can feel an algebra problem taking shape right there. Notice all of these rules or properties have to do with isosceles trapezoids. We can't do a whole lot unless the legs are congruent. It's just kind of a trapezoid. We can, however, talk about mid-segments. So let's take a quick mention about this first practice problems. The vertices of this trapezoid are, and they're pre-graphed for you. And then it says verify that it's an isosceles triangle or trapezoid. Keep getting those mixed up. So I'm going to tell you that we're going to work with a flow chart here. let's skip this and then we'll just spend some time working with the flow chart so that you know exactly how to go through it, to verify, to show your work, and to explain. So let's just jump right over to mid-segments. Now, 100 years ago, when I first started teaching geometry, we used to call these medians. So mid-segment of a trapezoid is also called a median. I like median better because we know that median is the midpoint and it's in the middle, right? And that means that I know that in this isosceles trapezoid, the bases are AF and CD. Notice it's drawn crooked. I know that B is the midpoint of this side, therefore those two segments are congruent. I know that E is the midpoint of this side, so FE and ED are congruent. So I like the word median better, but the book calls it a mid-segment, so just be accustomed to those two things. The other part about that mid-segment or that median is that not only do you get congruent pieces, but it's also parallel to both bases. So notice AF and CD, the two bases have the parallel arrows, but so does BE. BE is the mid-segment or the median of that trapezoid. Now, thankfully, we get to do a little bit of math. Let me put some words out here first, see if you can kind of digest this. The mid-segment is equal to half the length of the sum of the bases. Half the length of the sum of the bases. So sum of the bases means we add the lengths of the two bases together, right? And then we take half of it or divide by 2. I like the divide by 2. So here's how I wrote it out. In this particular case, BE, the mid-segment, is equal to the measure of AF plus the measure of CD, adding the two bases, the sum of them, all divided by 2. If you prefer, you could do, let's see, we could say mid-segment is equal to the sum of the bases over 2. Or if you're a fraction person, if you'd rather say the mid-segment is equal to half the sum of the bases, whichever one you like better. But that formula, if you write out the whole thing, is going to serve you well because then we can plug that in and we can do some math. So let's look at practice number 2. It says that MN is the mid-segment of trapezoid RSTU. Notice it doesn't have to be an isosceles trapezoid, it just has to be a trapezoid. Find X. Well, if it's a mid-segment, we know that these three guys are all parallel, right? We know a bunch of different things. We know M is the midpoint of RU. We know that N is the midpoint of ST. But we also know that the mid-segment is equal to the sum of the bases divided by 2 or half of that, whichever one you like better. So I didn't just say like, oh, this one's 10, this one's 20, figure out the mid-segment. I gave you some expressions. So the mid-segment is MN, so the length of MN is 30. The sum of the bases, so I'm going to add those two bases together. So I'm going to do a 3x plus 5 plus a 9x minus 5 all over 2. I'm going to combine some like terms here, and then I'm going to get rid of that fraction because nobody likes a fraction, right? So 30 is equal to, let's see, that'd be 12x, and those guys would cancel out. So 30 is equal to 12x over 2. Now, you might go ahead and just do that math, 12x over 2. I know some of you are going to. If you run into a situation where you're not sure what to do, multiply by 2 on both sides. That cancels those guys out. And then that just becomes a 30 times 2, which is 60. Divide by 12, and I get myself an x equals 5. So when x is 5, all the math works out, and that is the mid-segment or the median of that trapezoid. So be careful. Sometimes I give you expressions like I did for 3x plus 5 and the 9x minus 5. Sometimes I might just give you random numbers. Sometimes I might tell you the mid-segment and ask for the shorter base. So just be careful as you go through those. Watch what it's looking for. Know that this formula You can put stuff in exactly where it goes. So I think we can skip over this guy. Let's jump up to kites. Kites are the oddest of all the oddballs of this chapter because at least trapezoids, we talk about isosceles and we have things congruent. A rhombus is a squished square or flattened out square, crooked square. A kite is just its own random thing. It's a quadrilateral. It has two pairs of consecutive congruent sides. Two pairs of consecutive congruent sides. So when I look at this example that I gave you here, notice I kind of think of it as like splitting it up. Consecutive congruent sides. So in other words, if I split this part up, I've got these two sides are congruent. If I take this part of it, I've got these guys are congruent. That's the two pairs of consecutive congruent sides. They're not opposite sides are congruent. They're sides that are next to each other that are congruent. So sometimes it's tricky to see, so watch for those. And like the bottom example in this table, I noticed that sides JK and LK are congruent. So if I split that up, I would split it. Here's my one pair of congruent sides, and then here's my other pair of congruent sides. So just watch for how it's drawn. Sometimes that can be a little tricky. The other thing about this is that the opposite sides are not congruent or parallel. Be careful. Don't get falling into our trap of parallelograms. The opposite sides are not congruent. They are not parallel. They are not related to each other. The only relationship we've got is the two pairs of congruent consecutive sides. So just be careful. All right, there is a couple cool things, though, that fall in here. When we've got a kite, just like rhombi and squares, our diagonals do end up being perpendicular. So in this particular example, notice I've got the right angle drawn in. So segment BD is perpendicular to diagonal AC. Both of those diagonals are perpendicular to each other. The other property of kites is there is one pair of opposite angles that are congruent. And when I think of it, when I split this top one up here, where you do the splitting, that's where those angles are congruent. So in this case, angle P and angle R are congruent to each other. It's pretty apparent, I think, if you look at it, that S and Q are not congruent. So one pair of congruent sides. So K and M in this bottom table are not congruent, but angle J is congruent to angle L. And again, it's all about how you split it. Here's my pair of congruent sides. Here's my other pair of congruent sides. So that split mark, that's where my angles are congruent. I don't know if that helps you to see it or if it makes it more confusing. All right. So let's do an example or two. Let's talk about problem number 4, I think. Problem number 4, FGHJ is a kite. Find the measure of angle GFJ. These guys get a little bit tricky, right? So let's see, GFJ. So this is my X right here. This is what I'm looking for. I notice I've got my two pairs of congruent sides. If I split it up, I would have this top split here. So those two guys are congruent. These two guys are congruent. Well, I feel like we're going to need to go back to like, I don't know, section 6.1. This is a quadrilateral, right? This is a four-sided figure. How many degrees are inside a four-sided figure? So n is equal to 4. Perhaps this formula will ring a bell. Perhaps you already have that memorized and know it anyway. So the sum of the interior angles, didn't know I was going to throw a little refresher at you, did you? Sum of your interior angles is equal to four-sided figure minus 2 times 180. So I believe that's going to be 360 degrees inside that kite. Well, here's the thing. I'm already using these two measurements. 72 and 128 degrees are already used. So 360 minus 128 minus the 72, I think that comes out to 200. I think I've got 160 degrees left. So I have 160 degrees between angle F and angle H. But the important thing to remember on that table was the bottom thing, or the second thing on that table, exactly one pair of opposite sides are congruent. So this angle F has to be congruent to angle H. And if I've got 160 degrees to split evenly between them, I know that angle, I'm just going to call it angle F, is equal to 80 degrees. Angle H is also equal to 80 degrees. So sneaky problem, I had to use some old stuff. Remember the beginning of chapter 6. Problem number 5, W, X, Y, Z is a kite. Find Z, Y. So find this right here. I'll put an X there. Ooh, this is a really good problem. This is a nice throwback. There's something important about a kite. What do you know? It drew the diagonals in, right? All we know are little pieces inside the diagonals. We don't know any angles. We don't know anything about the sides. However, there's something really important we know. I believe, didn't we say something about the diagonals of a kite being perpendicular? Right? That was the first thing we talked about in the kite section. So if this is perpendicular, so let me take this triangle out. So that's where I just put that right angle. This is P, Z, and Y. I put an X on ZY. I know that PZ is 8. I know that PY is 24. This is really a throwback. What do you do to find the missing side of a right triangle? Everybody's thinking it, right? We're going to do a little Pythagorean theorem. A squared plus B squared equals C squared. C has to be the hypotenuse. It doesn't matter what A and B are. So 8 squared plus 24 squared is equal to X squared. Go ahead and solve from there, and you will get yourself an answer for that missing side. We pull in a lot of stuff from other classes from earlier in the year, and you have to kind of be able to go back and rethink those things. And when I did this problem, I ended up with 640 is equal to X squared. So then, of course, I'm going to square root that because nobody ever asked what X squared is. And I believe it comes out to approximately a 25.3. Tell me if I did it wrong, but I think that's correct. So that's it for chapter 6. I'm hoping that everything's kind of falling into place. I want to mention this problem right here. We will work on this using a flow chart again. That flow chart's really going to come in handy. You're going to want to use that when you go to do a test. And that should do it for chapter 6. Let us know if you've got any questions. If something's not making sense, make sure you ask. Otherwise, thanks for sticking in there for chapter 6.